Welcome to Maths for You channel, a past question on mechanics from Cambridge International past paper. A particle P is projected from a point O on a horizontal ground. At the instant t seconds after projection, the horizontal and the vertical upwards displacement of P from O are x and y respectively. The equation of the trajectory of P is y equal 3x minus 0.05 x squared. Find the angle of projection and the initial speed of P. Okay, I put a little sketch to put all the information given in that question. So O is on the ground, horizontal ground, and the projected with the speed of u, which we don't know, and the projection angle is theta. Again, we need to find. And that's a path. On the path, xy, so just we can take any point on the path as an arbitrary point, x and y. So I just put out x and y here. So x is the horizontal distance that the particle traveled, and the y is the vertical distance the particle traveled from the projection point. And the equation of the path is y equal 3x minus 0.05 x squared. The initial speed is u with the angle t. We can separate that velocity or speed horizontally and vertically because of we are going to use equations, the Sweat equation, on those directions. So horizontally, u cos theta, simply u cos theta. Vertically, u sin theta. Those are the speed horizontally and vertically, and we're going to use Sweat equation. That equations. So the first one we are using S equal ut plus half at squared. That's the one we're using it. But A is gravity. Here we are using gravity. So A is g, but the horizontally g is 0. Therefore, only S equal ut. So S is x, the distance, horizontal distance. X equal u cos theta t. And then the same equation, S equal ut plus half at squared, but this direction, that will be A equal minus g. So just y equal the vertical distance y equal u sine theta times t minus this minus half gt squared. From the first equation, we can find t in terms of x and u. So t equal x over u cos theta. And then substitute that value into the next equation, the vertical equation, y equal u sine theta. And instead of t, x over u cos theta minus half g x squared over t squared is x squared over u squared cos squared. So here on this side, y equal x sine theta cos theta, x sine theta cos theta is tan theta, x tan theta, minus half g x squared over u squared cos squared. I assume the g is 10 meter per second squared, which is 9.8, but I just took it as 10. They haven't given to us, so I just took it as, all you have to do, tell them, you assume that g is 10 meter per second squared. So if I could substitute that, x tan theta minus the half is 0.5 times g is 10, x squared over u squared cos squared. Then at the same time, that what that gives us, y equal, it's a equation of the path. But the path of the equation, we know that y equal 3x minus 0.05 x squared. So if you compare them both, this one and this one, compare both. What we have, tan theta, instead of tan theta, here 3. So tan theta equal 3. Theta equal tan inverse 3. So we have found the projection angle simply. And then equate the next part. Next part is what the coefficient of x squared. Coefficient of x squared in the given equation is 0.05. But here the equation we found 0.5 times 10 over u squared cos squared theta. So if you equate them, 0.5 times 10 over u squared cos squared theta times is 0.05. From that, if you work it out, it's just simple. It's just 0.5. If you divide that, it's 10. So this will be 10. So 10 times 10 is 100. Cross multiplication, u squared equal cos squared theta. From that, u is 100 over cos squared theta. But cos squared theta, before we complete it, we know tan theta is 3. So I'll put a little right angle triangle. So tan theta is opposite over adjacent. From that, Pythagoras, this hypotenuse is root 10. It's 3 squared, 9 plus 1, root 10. So from that, we can find cos theta equal 1 over the adjacent over hypotenuse, which is 1 over root 10. So we're going to use that. So u squared equal 100 over cos squared. That's one. And 100. And cos squared is this one. Cos squared is 1 over 10. 1 over 10. If you put 1 over 10, if you actually flip over, then it's 10. That is if u equal plus or minus, but minus, it can't be minus, so plus 10 root 10 meter per second. That's u. Right, next question. Find the coordinates of P at the instant when OP makes an angle of 45 with the horizontal. So I just keep that P there. So I just put a little line, and the angle is 45, alpha is 45. Find the coordinates of P, right? So x, y we need to find with the angle here. Okay, tan 45, that y over x, the height opposite over adjacent. So y over x. From that, tan 45 is 1. Therefore, x equal y. If you substitute that, y equal 3x, blah, blah, blah. So y is equal x. So x equal 3x minus 0.05 x squared. Then if you sort of bring that x squared on this side as 0.05 x squared, and if you bring that 3x to this side is minus 2x, x minus 3x is minus 2x equals 0. Then if I divide both sides by 0.05, that is only x squared, and 2 divided by 0.5 is 40, x equal 0. Then x common, x minus 40 equals 0. So there are two values, x equals 0, x equals 40. X equals 0 at O. X equals 40 is the one we want. So the coordinates of P, x coordinates of P is 40. But x equal y. Therefore, y coordinates is 42. So coordinates of P with an angle 45 degrees, the OP making 45 degrees is 40, 40. Next one. For the instant when P is at its greatest height above the ground, we calculate the height and the corresponding value of T, right? At the greatest height, the v, the vertical velocity, is 0 because of its turning the path turned the other way. So from that, we know v equal, this is Sweat equation, v equal u plus at. So v is, we're using that, v equal u sine theta minus gt. U is, v is 0, so this is 0. I bring that the u sine theta on this side, this side of the equation. So we know g is 10, u is 10 root 10, and sine theta equal 3 over root 10 from the previous. So u 10 root 10 times 3 over root 10 minus 10t equals 0. From that, we found t, 10 times 3 over 10, 10 cancel. That's 3 seconds. So we know the time, but what this says, the greatest height we need to get. So the greatest height is simply x equal, so I'll just simply h, we want it, but x is the horizontal distance with the time, 3 seconds. So how far it reached horizontally in 3 seconds. So x equal u cos theta t, u cos theta, u is 10 root 10, and cos theta equal 1 over root 10, and 3. Root 10 cancel out. That would be 30 meter x, but we don't need that x, but we want y. But we know the equation y equal 3x minus 0.5x squared. Therefore, substitute x, 3 times 30 minus 0.05 times 30, x squared is 30. So 3 times 30 is 90, 0.5, you do that is simply 3 times 3. So that's 45. 90 minus 45, 45 meter. So y maximum, or the greatest height, is 45 meter from the ground. Thank you. Please subscribe to the channel and share the contents with your friends and other students. Thank you.